there, welcome to Chemistry Chapter 15, homework number 3 solutions. We're going to be on page 522 and also 520, looks like 524. And we're going to go over review questions 6 through 10 and practice problems 9 through 11. So if you could open your book up to page 522, instead of putting the book on the screen, I'll just read through the question. So number 6 says, why are acid ionization reactions important in chemistry? Well, those acid ionization reactions determine the strength of the acid. So depending on how well they split into their constituent ions, that determines the strength of the acid. So if they are 100, if they split into their constituent ions 100%, and you have only products and no reactants left. So if you look down at this reaction here, here's an acid ionization reaction on practice problem number 9. If that HCN splits into H plus and Cn minus, and there's really only products and no reactants left, then that's a really strong acid. Now in this case, this isn't a strong acid. All right, number 7. What are the limits of the pH scale? That's 0 to 14. Number 8 says 3 solutions have the following pH levels. It's 11, 8, and 2, which are acidic. Well, it's only something with a pH under 7, so that would be solution C. Right, number 9 says 3 acid solutions of equal concentration have the following pH levels, and there are 4, 6, and 1. Which acid has the lowest ionization constant? That would be B. That's the highest pH, therefore it's the weakest acid. So the lower the acid ionization constant, the weaker the acid. But it's the higher pH when it comes to acid. Okay, number 10 says, where does acid rain come from? That's contaminants in the air that react with water. So I gave an example, sulfur trioxide gas. If you have a smokestack or something like that that's putting out sulfur trioxide, it's going to react with liquid water, and that will make sulfuric acid, and that comes down in the form it's mixed with the rain and can do a lot of damage to plant life. Okay, so that's it for the review questions in Chapter 15. So practice problem 9 through 11, and 11 is one that I added. It should be written in your book. But we want to know with number 9, what's the equation for the acid ionization constant for HCN? Now, the first thing you have to do is write the equilibrium reaction. All right, then you can get K sub A. So HCN, as an acid split into their constituent ions. So that would be H, hydrogen, so H plus ion, and Cn minus. That's cyanide, one of those you memorized in Chapter 9. And so you have that negative charge there. And then K sub A, the formula for that is the concentrations of the products divided by the concentration of the reactants. So concentration of H plus times the concentration of Cn minus divided by the concentration of HCN. So we call that K sub A. So number 10, what is the base ionization equation for SO4 2-. So with a covalent base, let's say a non-hydroxide base, what we do is we add liquid water as one of the reactants. So SO4 2- is going to combine with one of the hydrogens from the water to make HSO4, but that H plus will reduce the charge from a 2- to a 1-, right? We're adding a positive charge, so it reduces. And then what's left of that H2O is a hydroxide ion, all right? So this is always going to be the way you do a covalent or non-hydroxide base. Okay, so now that we have the equilibrium reaction, K sub B is just going to be the 2 products divided by the reactant, but we don't include liquids or solids, so we're not going to include the water. So it's going to be HSO4- times OH-, those are concentrations in molarity, divided by SO4 2- concentration. And then finally, I wanted to add in an example of a hydroxide base. So what is the equation for the base ionization constant for KOH, so our hydroxide base? Well, that's more like an acid. You don't have to add liquid water. It's going to split into its constituent ions. So potassium is in column 1, so it has a plus charge. And then hydroxide, and of course everything except when you have liquid water in the previous example, everything is aqueous. So we have a hydroxide ion, so K plus OH minus. Now, you occasionally will have to balance the equation, but on these 3 examples, we didn't have to balance. I believe on the extra practice or extra practice problems, you will have to balance the equation, but this is already balanced. So K sub B would be the concentration of potassium times the concentration of hydroxide divided by the concentration of KOH. Okay, so no math in this set of homework. Really, the only math you have are when you are actually having to plug in numbers for the equilibrium constant. All right, so we did that on the first 2 or 3 practice problems there. All right, that'll do it for this homework solution videos. I will talk to you on the extra practice problem video for Chapter 15 if you need to watch it.